In this video, we are going to practice some more with solving systems of inequalities by graphing. One thing I do want to remind you guys of is that whenever you have an inequality that is greater than or an inequality that is less than, you want to make sure that the line you draw in is going to be dashed. And if you have an inequality that is greater than or equal to, or an inequality that is less than or equal to, you want to make sure that the line you draw in is going to be solid. So let's look at number 1. We have y is greater than -1 and x is less than 0. So if we want to graph y is greater than -1, we first need to find our -1 on our y-axis. So that's going to be down here. And since we have a greater than sign, we want to make sure we use a dashed line. And since y is greater than -1, all the numbers that are going to be greater than -1 are going to be above this. So that's why we need to shade in above that line that we drew. If we want to draw the line x is less than 0, we need to find 0 on our x-axis, which is going to be right here. And we need to draw a dashed line again because we have a less than sign. And all of the numbers that are less than 0 are to the left of that line, so we need to shade in to the left. And the place where those two shaded areas intersect or overlap, so where the green and the red are in the same area, is going to be where we have our solution to our problem. So anything here is going to give us the correct solution. Let's look at number 2. We have y is greater than -2x plus 2, and y is less than or equal to x plus 1. So these equations are a little bit tougher, but we've seen stuff like this in the past. This is in the form y equals mx plus b, where m is our slope and b is our y-intercept. So if we want to put our y-intercept on the graph for the first one, we want to move all the way up to +2. So +2 is going to be right here. And then we need to apply the slope of -2 to that point. So that means we are going to go to the left 2, so 1, 2, and up 1. We're going to go to the left 2 and up 1. And so now we can connect those points to draw in our line, but be careful when you do. Remember, we have a greater than sign, so we need to have a dashed line. And if we have that y is greater than -2x plus 2, are we going to shade above that line or below it? Well, greater than means bigger, so we have to shade above that line. What about y is less than or equal to x plus 1? This time our y-intercept is going to be +1, which is down here. And we need to apply a slope of 1, because if there's nothing written in front of the x, that just means our slope is 1. So that means we have to go to the right 1, up 1, to the right 1, up 1, to the right 1, up 1, and so on. But this time, since our inequality is less than or equal to, we need to make sure that we draw in a solid line. So when I connect these points, I want to make sure it's a solid line. And so, since y is less than or equal to x plus 1, I am going to have to shade underneath that line because less than is below. So again, wherever our two shaded areas intersect or overlap is going to be where we have our solution to this problem. So anything in this region right here. Let's look at the last problem. For number 3, the first inequality we have, y is less than x plus 1, is very similar to the one that we had in number 2. The only thing that changed is now we have a less than sign, and before we had a less than or equal to. So we know how to graph this one already. Our y-intercept is going to be a positive 1, and our slope is 1, so we need to go to the right one, up 1, to the right one, up 1, and so on. The only thing that's going to be different this time is we need to draw in a dashed line instead because we have a less than sign. And if it is going to be less than, everything that is below that line is going to be what we're looking for. But now, the second inequality we have, 3x plus 4y is greater than or equal to 12, is something a little bit different. This one is in the standard form, which is ax plus by equals c. And so the easiest way to graph a line from standard form is to find the x and y intercepts. So the x-intercept is going to be when y equals 0. So let's plug y in to our inequality and see what we can get out. So if y is 0, we have 3x plus 4 times 0 is greater than or equal to 12. Well, we know that 4 times 0 is 0, so we have 3x is greater than 12. And to get x by itself, we want to make sure that we divide both sides by 3. So these are going to cancel out, and we are going to be left with x is greater than or equal to 4. So we can plug 4 into our table, and then we want to find our y-intercept, and our y-intercept is going to be when x equals 0. So now we need to plug 0 in for x. So 3 times 0 plus 4y is going to be greater than or equal to 12. 3 times 0 is 0, so we're left with 4y on the left side is greater than or equal to 12. And to get y by itself, we have to divide both sides by 4. And so these 4's are going to cancel each other out. So we're going to be left y is greater than or equal to 3. So we can plug 3 into our table. So let's plot these points onto our graph. 4, 0 is going to be 4 to the right, and then going up and down 0. And then our 0, 3 is going to be going left to right 0, and up 3. So we can connect those 2 points with a solid line because it is greater than or equal to. Now the question is, am I going to have to shade above that line or below it? Well, greater than or equal to means that it's going to be bigger, so we have to shade everything above that line. And so our solution to this problem is going to be anything that is in the region where both of these, the red and the green, are shaded.